Let us go back to making pancakes and see, based on the recipe that we have, we can make 5 pancakes, right? But what if we had 3 cups of flour, 10 eggs, and 4 teaspoons of baking powder? How many pancakes can we make with that amount, okay? And so we say, okay, no problem. Let us use our recipe and say for 3 cups of flour, I can make, for every 1 cup of flour, I can make 5 pancakes. So I can make 15 pancakes. Now for with 10 eggs, I can make, for every 2 eggs, I can make 5 pancakes. And so that will give me 25 pancakes. Okay, now for the amount of baking powder that I have 4 teaspoons. And I know for every half a teaspoon, I can make 5 pancakes. And so this will give me 40 pancakes. So you see, each ingredient will give me a different number of pancakes, theoretically. Okay, so theoretically, if I have 3 cups of flour, I can make 15 pancakes. However, these ingredients must go together in order to make pancakes. So if I have a limiting reactant, then no matter how much extra I have of the other reactants, then I still will not be able to make any more. So here you see my limiting reactant, or my limiting ingredient, is 15 pancakes. So no matter, I can't make 25 pancakes, I can't make 40 pancakes because I've run out of flour. So flour is my limiting reactant. Now let's talk about one more thing, and that's actual yield and percent yield. We've seen we can calculate theoretically how many moles or how many pancakes can we make, or how many moles of a reactant we can make to make a certain product. But let's say that we spill some of the batter, we burn some pancake, we drop one on the floor, or some other uncontrollable event, we make only 11 pancakes. So the actual amount of product in a chemical reaction is the actual yield. And we can determine the efficiency of the pancake making process by calculating the percentage of maximum number of pancakes we actually make. In the chemical reaction, we call this percent yield. And our percent yield is our actual yield, what we actually got, divided by our theoretical yield, what we calculated we should get, times, of course, 100. So if we made 11 pancakes, if we ended up putting 11 pancakes on the plate, but we really had enough ingredients to make 15, then we take 11 divided by 15 times 100, and it gives us 73% yield. So our percent yield is 73. Let us summarize what we've just learned about pancakes and about chemical reactants, and then we will do a couple of examples to understand how this applies to chemical reactions. So the limiting reactant, or the limiting reagent, is the reactant that is completely consumed in the chemical reaction. When we make our pancakes, we will not have any flour. Our theoretical yield is the amount of product that can be made in a chemical reaction based on the amount of the limiting reactant. So theoretically, if we have 3 cups of flour, we can make 15 pancakes. That's our theoretical yield. But we get something called an actual yield, which is the amount of product that we actually produce in the chemical reaction. And then figure out what our percent yield based on how much we actually got, our actual yield, divided by our theoretical yield times 100. Okay, let's do an example. What is the limiting reactant and the theoretical yield when 0.552 moles of aluminum react with 0.887 moles of chlorine gas? And we want to look at our solution map, and we want to figure out the moles of aluminum that we have. We want to convert it to moles of our product here, which is aluminum chloride, right? And then we also want to take the other reactant or the other ingredient of chlorine gas, and we want to convert from moles of chlorine to moles of aluminum chloride, right? And the smallest amount that we have is going to be our theoretical yield. Let's do aluminum first. If we have 0.552 moles of aluminum, we know that we can use our balanced chemical equation to figure out the molar ratio of aluminum to aluminum chloride. And we know that for every 2 moles of aluminum, there is 2 moles of aluminum chloride. So this is just really multiplying by 1 because it cancels out. So we have 0.552 moles of aluminum chloride of our first reactant. Now let us do it for our second reactant, which is 0.887 moles of chlorine gas. And we know that there's 3 moles of chlorine gas for every 2 moles of aluminum chloride. And this gives us a yield of 0.585 moles of aluminum chloride. So, which one is the smallest value is this here. So this is telling us that our limiting reactant is aluminum. So it doesn't matter if we have extra chlorine, we are limited by how much aluminum we have, and we can only make 0.552 moles of aluminum chloride. Okay, so this is our limiting reactant, and our theoretical yield is our limiting reactant is aluminum, of course, and our theoretical yield is 0.552 moles of aluminum chloride. Okay, go ahead and give this a try. If we begin with 1.8 moles of titanium and 3 moles of chlorine, what is the limiting reactant and theoretical yield of titanium chloride in moles? All right, let's start with what we're given. We have 1.8 moles of titanium, and let's see how much titanium chloride we get. Let's use the molar ratio. We have 1 mole of titanium for every 1 mole of titanium chloride. And so we should end up with 1.8 moles of titanium chloride. But we have another reactant, and this is 3.2 moles of chlorine gas. And now we know for every 2 moles of chlorine gas, we are producing 1 mole of titanium chloride. And so we get 1.6 moles of titanium chloride. That means what? That chlorine gas is our limiting reactant. So this is our limiting reactant. And our theoretical yield is 1.6 moles of titanium chloride.